Okay, so here we go. This one, I now have a boy throwing a ball upwards from a height that's 1.2 meters off the ground with an initial velocity of 5.18. So I'm going to try to draw this scenario. I'm a really terrible artist because that's why I teach physics, because art is not my thing. But basically, if you visualize it, the ball is going to go up and down. And I know this initial distance, the distance from his hand to the ground, is this 1.2 meters. And I know when it leaves his hand, it must be going at 5.10 meters per second, because that's what it says in the question. It makes a lot of sense, right? When I throw a ball up in the air, it does start off with a velocity. So that initial velocity, or V1, is going to be my 5.10. Excellent. And I know that my height off the ground is 1.2, but that's only the height from here to here. That's my 1.20 meters. So although it's not useful yet, it will be useful in a little while. Then it asks me, what is the maximum height of the ball? Now there's some things we have to think about. When the ball goes up, it's going to slow down as it goes up. So that means as it goes up, when this 5.10 meters per second is true, the acceleration is going to be negative 9.8 because it starts off and then it slows down. So that means I can automatically assume it's negative on the way up, because when this is happening, this will happen at the same time. It asks at the maximum height. So I want to know the maximum height of the ball, which means I only want to know how high up it goes. At that top, V2 is going to be 0 because the ball will stop and momentarily before it turns around. It's really fast, faster than you can really think about, but it is actually stopping before it comes back down. This gives me my 3 pieces of information, and I want to know what D is. What is the distance that it goes up? So pick myself an equation, same thing, right, that we've been doing. Pick an equation, substitute, and whatever math I need to do to solve. So V2, well, V2 squared, 0 squared is 5.10 squared plus 2 times my negative 9.8. That negative is super important. Otherwise, you'll get a weird answer. And I'm good. So I'm going to simplify a little here. I'm going to square my 5.1 and my 0. I know that 0 squared is 0. I know 5.1 squared, when I put it on my calculator, is 26.01. I know that doubling this will give me 19.6. So I have those numbers. I'm good to go. Now I just need, don't forget the D, I need to now simplify. This is going to come to the other side and become negative, right? Remember, you don't have to write these down. This is just for those that are watching the video to understand the math in case they need it. And then this is multiply. When I move it over, it'll divide. A negative divided by a negative gives me a positive, which is really useful because it should be positive, right? It goes a positive distance because it's moving away from the hand, the starting point. So I'm just going to divide, and I find it goes. Now, sig fig wise, I'm going to get 2, so it's going to go 1.3 meters. I get 2 because of the 9.8. Remember, it does count. There we go. Now, that's very logical. I can throw a ball 1.3 meters into the air. That is very possible, so that helps me. If I got 27 or something ridiculous, I know I was wrong. But this is the height above the hand. It's actually not the height off the ground. So I'd be very tempted to actually say the height off the ground, because when we measure height, we tend to measure it to the ground, is the 1.3 meters I just calculated plus the original 1.2. Remember, I said this would be helpful, and it is now. So I'm going to add those, and then I get my answer of 2.5 meters. There we go. Part A.